A planet could, in theory, orbit just outside a supermassive black hole's event horizon and stay warm enough for liquid water, thanks to the black hole's bizarre effect on cosmic background radiation. Keep watching, because I'll reveal exactly how time would pass for life on such a world, and why a single day there could outlast all of human history. Let's start with the basics. Black holes are famous for being the ultimate cosmic destroyers. But what if they could also be unlikely cradles for life? The idea sounds like pure science fiction, but recent research has uncovered a scenario so strange, it almost feels like a cosmic loophole. Around the largest, fastest spinning black holes, those with masses over 160 million times that of our Sun, there's a razor-thin orbital band where the rules of physics get turned inside out. Here, the black hole's immense gravity bends and amplifies the cosmic microwave background, the faint glow left over from the birth of the universe, until it becomes as warm as a summer's day on Earth. This isn't just a theoretical curiosity. Calculations show that in this narrow region, a planet could actually have liquid water on its surface, the gold standard for habitability as we know it. But how does this work? Normally, the cosmic microwave background is barely above absolute zero, far too cold to warm anything. Yet, near a rapidly spinning supermassive black hole, the warping of space and time acts like a cosmic magnifying glass. The background radiation gets blue-shifted, its energy boosted, until it's strong enough to heat a planet to temperatures where water can stay liquid. This is the first payoff. A black hole, usually seen as a destroyer, could in theory provide the energy needed for life, not by shining like a star, but by bending the very fabric of the universe to create a habitable zone. Of course, this raises a huge question. What kind of black hole could actually allow this, and how close could a planet get before being torn apart? The answer lies in the difference between ordinary and supermassive black holes. Smaller black holes, like those formed from collapsing stars, have such intense tidal forces near their event horizons that anything venturing close would be ripped to shreds. But supermassive black holes, the kind lurking at the centers of galaxies, have event horizons so vast that the gravitational gradient is much gentler at the same relative distance. This means a planet could, in theory, orbit safely just outside the point of no return, in a region where the blue-shifted cosmic background is just right for life. Only the biggest, fastest spinning black holes create this narrow, stable zone. If the black hole isn't massive enough, the habitable band is either too close to survive or doesn't exist at all, and if it isn't spinning rapidly, the necessary warping of space-time just doesn't happen. So the conditions are incredibly specific. Think of it as the universe's most exclusive real estate, a thin ring where the laws of physics conspire to make life possible in the unlikeliest place. But even if a planet could survive in this cosmic sweet spot, what would life there actually experience? This is where things get truly bizarre. The gravity is so intense that time itself slows down dramatically compared to the rest of the universe. For any life on such a planet, a single orbit could feel like a normal day, but for the outside universe, thousands or even millions of years might pass. This opens up a whole new set of questions. How would evolution work in such a warped timeline? Would civilizations rise and fall in what feels like an instant to the rest of the cosmos? And what about the view? Would the sky be filled with strange, distorted images of the universe beyond, twisted by the black hole's gravity? We've only scratched the surface of what's possible in these extreme environments. The idea that a black hole could host a habitable zone challenges everything we thought we knew about where life could exist. It's a testament to the weirdness of the universe that, under just the right conditions, even the most hostile objects in space might offer a tiny sliver of hope for life. But as we'll see next, forming a planet in such a place and keeping it safe from the black hole's many dangers is a whole new challenge. What kind of worlds could actually survive here, and what cosmic hazards would they face? The answers might surprise you. While the idea of a habitable planet near a black hole sounds wild, the next big question is, how could such a world actually come to exist in the first place? It turns out the universe might be more creative than we give it credit for. Instead of imagining a planet somehow wandering into this cosmic danger zone, recent research suggests that planets could form right in the swirling disks of gas and dust that surround supermassive black holes. These disks, which can stretch for light years, are not just chaotic maelstroms. They're also fertile ground for planet formation, much like the disks that gave birth to our own solar system. In fact, some models predict that tens of thousands of planets could be born in these extreme environments, creating a kind of cosmic real estate boom right at the heart of galaxies. But what would it take for a planet to survive in such a place? The environment around a supermassive black hole is anything but gentle. The accretion disk glows with intense radiation, especially in the ultraviolet and X-ray parts of the spectrum, and the galactic core is crowded with stars, supernovae, and cosmic rays. At first glance, it seems impossible for life to gain a foothold here. Yet there's a surprising twist. If a planet has a thick, hazy atmosphere, think of something even denser than Venus's clouds, it could act as a natural shield, blocking out the most dangerous radiation and allowing more benign energy to filter through. This atmospheric armor could make the difference between a scorched wasteland and a world where chemistry and maybe even biology can thrive. Now here's where things get even stranger. The black hole's gravity doesn't just bend light. It can also create bizarre day-night cycles for any planet lucky enough to orbit in the habitable band. As the planet moves around the black hole, the immense gravitational lensing can focus and distort the cosmic microwave background, casting the black hole's shadow across the planet's surface. This means that even without a sun, a planet could experience periods of light and darkness, an essential ingredient for regulating climate and possibly even for the rhythms of life. Imagine a world where night is literally the shadow of a black hole, and day is the amplified glow of the universe itself. But before we get too carried away, let's not forget the dangers lurking in this cosmic neighborhood. The galactic center is a crowded, violent place, with stars packed thousands of times more densely than in our own solar system. Supernova explosions, close stellar encounters, and powerful jets from the black hole itself could all threaten the stability of any planet's orbit or atmosphere. Even if a planet forms in the right spot, it faces a constant barrage of hazards that could strip away its atmosphere or sending it spiraling into oblivion. The odds are long, but the sheer number of planets that could form in these disks means that somewhere a few might beat the odds and hang on long enough for life to get started. Hey Curious Squad, before moving forward, make sure to hit like and subscribe if you're fascinated by the idea of planets forming in the most extreme places in the universe. There's so much more cosmic weirdness to explore, and you won't want to miss what's coming next. So, what would the climate and seasons be like on a planet orbiting so close to a black hole? The answer is as mind-bending as you'd expect. The gravitational forces at play are so intense that they can twist and tug at a planet's axis, potentially causing wild swings in its tilt over time. This could lead to dramatic changes in climate, with seasons that are unpredictable and extreme. On the other hand, some orbits might be stable enough to keep a planet's tilt relatively steady, offering a rare pocket of calm in an otherwise chaotic environment. The interplay between gravitational chaos and stability is one of the great open questions for scientists studying these exotic worlds. And what about the chemistry of life itself? The unique mix of radiation, atmospheric shielding, and gravitational effects could drive chemical reactions unlike anything we see on Earth. some researchers speculate that life here might evolve to harness the energy of the cosmic microwave background, or develop biochemistries adapted to high radiation levels. The possibilities are vast as the universe itself, and we're only beginning to scratch the surface of what might be possible. But even if a planet manages to form, survive, and develop a stable climate, there's still the ultimate question: could life actually take hold and thrive in such an alien environment? And if it did, would we even recognize it as life? The answers to these questions might challenge everything we think we know about biology and the limits of habitability. In the next part, we'll dive into the ultimate test. What would it really take for life to not just survive, but flourish in the shadow of a black hole? If a planet could form and survive in the shadow of a supermassive black hole, the final and most mind-bending question is, could life actually take root and flourish in such an extreme environment? The answer takes us deep into the heart of physics, biology, and the limits of our imagination. The first challenge is time itself. Near the event horizon, the black hole's gravity is so intense that time slows dramatically compared to the rest of the universe. For any living thing on such a planet, a single day might stretch out to thousands or even millions of years for an outside observer. This isn't just a science fiction twist. It's a real consequence of Einstein's theory of general relativity. Imagine a civilization evolving, building, and perhaps even vanishing, all while the rest of the cosmos barely notices a blink of an eye. But what would this mean for the evolution of life? On one hand, the slow passage of time could give life on the planet a unique advantage, more subjective time to adapt and evolve, even as the universe races ahead outside. On the other hand, this time dilation could create strange evolutionary pressures. For example, cosmic events like supernovae or gamma-ray bursts that threaten life elsewhere might seem to happen in fast forward, giving life little time to react. The planet's climate, too, would be shaped by these warped timelines. Weather patterns, seasons, and even geological processes could unfold at a pace that's almost incomprehensible from our perspective, making the rhythms of life on such a world utterly alien. Then there's the question of planetary tilt or obliquity. On Earth, our relatively stable tilt gives us predictable seasons, but near a black hole, the gravitational forces can twist and wobble the planet's axis in wild ways. Some orbits might be so chaotic that the planet's tilt swings dramatically over short periods, leading to extreme and unpredictable climate shifts. This could make it incredibly hard for complex life to gain a foothold, as ecosystems would be constantly adapting to new and harsh conditions. However, recent research suggests that not all orbits are doomed to chaos. In certain configurations, a planet's tilt could remain stable for millions of years, providing a rare window of opportunity for life to emerge and persist. The chemistry of life in such a place would likely be just as strange as the physics. With a thick protective atmosphere, life might evolve to harness the unique energy sources available, perhaps even using the blue-shifted cosmic microwave background as a kind of sun. High radiation levels could drive rapid mutation, leading to forms of life that are resilient, adaptable, and unlike anything we've ever imagined. The interplay between radiation, atmospheric chemistry, and gravitational effects could spark evolutionary pathways that are completely foreign to us, challenging our very definition of what it means to be alive. But even if life does arise, would we ever be able to detect it? The signals from such a planet would be faint, distorted, and delayed by the black hole's gravity. Traditional methods of searching for life, like looking for atmospheric biosignatures or radio signals, might not work at all. Instead, we might have to look for indirect clues, unusual patterns in the light from the accretion disk, strange periodic dimming, or even the telltale heat signature of a planet clinging to existence in the black hole's shadow. The search for life in these places would push our technology and our imagination to the absolute limit. And if we did find evidence of life, would we even recognize it? The extreme conditions near a black hole could give rise to forms of life that defy our expectations. Organisms that thrive on radiation, communicate in ways we can't detect, or experience time so differently that their entire history unfolds in what seems like an instant to us. The possibility is both thrilling and humbling, reminding us that the universe is far stranger and more diverse than we can possibly imagine. So what do you think? Could life really survive in the shadow of a black hole? Or is this just a cosmic fantasy? Let us know your thoughts in the comments below. And to learn more, watch our other black hole videos on the end screens.